Hello everyone. This is our new lecture, and in this lecture we will study what are different classification of sensors. So in previous lectures we studied about the what are sensor, what is the sensor technology, what are the major differences between transducer and sensors, why we need sensors, what are direct and indirect sensor, what principle we can use for sensing, why semiconductors materials are important for sensing purpose. So in this video we will study about the classification of sensors. So all sensor may be of two kinds, passive and active. So one classification is based upon active and passive sensors. A passive sensor does not need any additional energy source. It generates an electric signal in response to an external stimulus. So external stimulus is applied to the sensor and it directly generates output readable signal without requiring any additional energy source. That is, the input stimulus energy is directly converted by the sensor into the output signal. The examples are thermocouple, a photodiode, and a piezoelectric sensor. In thermocouple, heat or temperature is directly converted into electrical signal. Photodiode is same thing, photons or light entering or falling off an object on photodiode can be directly converted into electric signal. So many passive sensor are direct sensor as we defined them earlier. The active sensor require external power for their operation. So active means there must a requirement of external source, power source, which is called an excitation signal. So they require excitation signal. That signal is modified, or modified, the second term we can use modulated by the sensor to produce the output signal. Means the external signal is manipulated by the sensor to produce the output signal. The active sensors sometimes are called parametric sensors because they are their own property changes in response to an external stimulus, and these properties can be subsequently converted into electric signals. So the another term which is known for active sensors are parametric sensor. So parametric, why? Because property of the sensor itself changes with external stimulus. So for example, a thermistor, it is a temperature sensitive resistor. Thermistor means temperature sensitive resistor. Means it will change its resistance with temperature. It does not generate any electrical signal, but by passing an electric current or excitation signal through it, its resistance can be measured by detecting the variation in the current or voltage across the thermistor. These variations in ohms directly relate to temperature through a known transfer function. So, how a thermistor will work? Uh, when heat is or when temperature is increasing or decreasing, so resistance is changed, but we can't measure resistance directly. So we will apply here what? Electric current. This electric current is also known as excitation signal. So we can directly know the value of changes in electric current or voltage, and these variations uh, can be calibrated in terms of ohms. So this change in resistance is directly proportional to the applied quantity to be measured. And another example of an active sensor is a resistive strain gauge. Resistive strain gauge in which electrical resistance relates to strain in the material. When some strain occurs in the material, then its electric resistance changes. Suppose we can change hair length, area, thickness. To measure the resistance of a sensor, here we also require an electrical current that must be applied to it from an external power source. So these two, thermistor and this resistive strain gauge, requires what? External signal, which is also known as excitation signal. That's why they are also known as parametric sensors. So these are active sensors that requires external signal for their operation, while passive sensors do not require any external energy source for their operation. They directly converts non-electrical stimulus into electrical stimulus. Passive sensor. The sun provides a very convenient source of energy for remote sensing. The sun's energy is either reflected, visible wavelength, or absorbed and then re-emitted, which is known as thermal infrared wavelength. So remote sensing systems which measure energy that is naturally available are called passive sensors. So what are passive sensors here? In case of remote sensing systems that can measure energy that is naturally available or the sun's energy. Passive sensors can only be used to detect energy when the naturally occurring energy is available. For all reflected energy, this can only take place during the time when the sun is illuminating the earth. But what happens when there is night? So there is no reflected energy available from the sun at night. Energy that is naturally emitted, such as thermal infrared, can be detected day or night as long as the amount of energy is large enough to be recorded. So in case of passive sensor, we can see that here in the figure that sun is illuminating the earth's surface and that then re-emitted energy, thermal infrared energy, if its amount is sufficient to be detected by the sensor, then these type of sensors can record the or detect the or measure the energy, reflected energy. So these type of sensors are known as passive sensors. While in the night time, how we can detect the energy? So in the same sensor can be used as active, same sensor can be used as passive sensor. So active sensor on the other hand provide their own energy source of illumination. The sensor emits radiation which is directed towards the target to be investigated. Firstly, this sensor will emit radiation towards the target, then radiation reflected from the target is detected as and measured by sensor. Advantage for active sensor include the ability to obtain measurement anytime, daytime or night time. Or active sensor can be used for examining wavelength. Active sensors can be used for examining wavelengths that are not sufficiently provided by the sun, such as microwaves, or to better control the way to target illuminated. However, active systems require the generation of a fairly large amount of energy to adequately illuminate targets. Some examples of active sensors are laser fluorescensor and a synthetic aperture radar, which are also known as SAR. So, by this figure, we can say that active sensors require their own energy source of illumination, and advantage is that they can measure the measurement from the active sensor can be taken at any time regardless of time, day or season. Now what are second classification? Second classification, it is based upon the uh, absolute and relative values. So depending upon the selected reference, sensor can be classified into absolute and relative sensors. So what is an absolute sensor? It detects a stimulus in reference to an absolute physical scale that is independent of the measurement conditions. So where a relative sensor produces a signal that is relates to some special cases. So in case of absolute sensor, a stimulus is to be referred on absolute scale. So we can clear it through the examples. An example of an absolute sensor is a thermistor, a temperature sensitive resistor. Its electrical resistance directly relates to the absolute temperature scale of Kelvin. Means the change in the resistance is directly uh, we can relate that change directly to absolute temperature scale of Kelvin. An example of an absolute sensor it is a thermistor, a temperature sensitive resistor. Its electrical resistance directly relates to an to the absolute temperature scale of Kelvin. Means change in resistance can be directly calibrated in terms of the temperature scale of Kelvin. And another very popular example of temperature sensor is thermocouple. Thermistor is a absolute sensor while thermocouple is a relative sensor. How it is relative? Because here we will take the measurement with reference to another terminal. It produces an electric voltage which is a function of temperature gradient across the thermocouple wires. Thus, a thermocouple output signal cannot be related to any particular temperature without referencing to a known baseline. So, in thermocouple, we have two points A and B, and we must have a temperature gradient between these 2 points, and this temperature gradient uh, is can be used for measurement of the temperature. So here we are taking reference of A point to with respect to B point. So in this way it is a relative sensor. Another example of absolute and relative sensor is a pressure sensor. An absolute pressure sensor produces signal in reference to vacuum. So absolute scale of pressure is a vacuum, and absolute zero or on a pressure scale. A relative pressure sensor produces signal with respect to a selected baseline that is not zero, or we can say that it can produce a signal with respect to atmospheric pressure. So it is always relative pressure. So this is second classification. And the third classification of sensor are based upon some of its properties, some of its application, some of its characteristics. So table 1 shows the sensor specification and table 2 shows the sensor material. Sensor specifications are specification we will study later. So in sensor specification we have different specification or sensor are specified according to these terms: sensitivity, stability, accuracy, speed of response. What is the speed of response of sensor? What is overload characteristics? What is hysteresis, operating life, cost, size, weight, resolution, selectivity, environmental conditions, linearity, deadband, output format. So table 2 shows the sensor materials. So conductor, inorganic materials that you can use: conductor, semiconductor, biological substance. And inorganic material you can have insulator, liquid gas or plasma or other materials. Detection means used in sensor. What different detection we can use in sensor? Biological detection may be there, chemical detection, electric, magnetic or electromagnetic wave we can detect, heat, temperature, mechanical displacement of waves can be detected, radioactivity, radiation can be detected. Conversion phenomena: how different type of conversion you can sense physically: thermoelectric, photoelectric, photomagnetic, magnetoelectric. Like you can see these chemical conversion requires chemical transformation like gas to water or liquid form, liquid to gas form, liquid to solid, like this. Biological transformation can be also used in the sensors. Field of application, there are various fields of application where sensor you can use: civil engineering, construction, distribution, commerce, energy, power, health, medicine, manufacturing, military, scientific measurement, transportation, automotive application, domestic appliances में, environment, meteorology, information telecommunication, marine, recreation, toys, space, others. Stimulus that you can detect: acoustic, biological, chemical, electrical, magnetic. In acoustic we may have wave amplitude, phase, polarization, spectrum, wave velocity, others. Biological, biomass you can detect, chemical components, concentration of states you can detect, electric charges, current, potential, voltage, electric field, conductivity, permittivity, and other parameter you can detect. Magnetic field, amplitude, phase or polarization, spectrum, magnetic flux, permeability, and other. Stimulus you can detect in magnetic as a magnetic stimulus. So these are the classification